I have no idea what that was. That's just what you call goofing. All right, so let's see. What we're going to look at is the first part of the test review, which we'll be covering in Chapter 1. So this is the part that I would expect students to be able to do without the assistance of a calculator. So to begin with, one of the earliest things that we learned how to do was how to work with angles and sketching angles and that kind of thing. So this problem number 1 says you're going to find angles, two angles, one positive and one negative, that are coterminal. So since we know that angles are off by 360 degrees and they become coterminal, what you would do to get the positive one is you would just add those two numbers together. Okay, then that would give the answer of that positive coterminal angle. So you can just do that to the side if you want to. 360 minus 35. Remember, we're doing this without a calculator, which is good for you. We live in a world that everything is so automated, people tend to forget the basics, and you need to think. All right, so that's 325. That would be your positive one. A negative coterminal angle, what you're doing is the negative 35, and now you're subtracting 360. So if you do that, you're just adding and keeping the negative. So if you do that, you would have negative 360, you're adding a negative 35, so that would be negative 395 degrees. So angles that are coterminal are just off by 360 degrees. Okay, you can keep adding 360, you can keep subtracting 360. Okay. Next problem, now this one is in radians, so it'd be the same thing. So if you wanted to find an angle that's positive, that's coterminal to it, well, you really add 360. However, 360 is the same thing as 2 pi radians. Okay, that's a real fundamental thing to remember, is 360 degrees is the same as 2 pi. So we're going to add 2 pi to get this. So what I'm going to end up doing on this is I'm going to just get a common denominator, and I'm going to deal with the arithmetic. So common denominator is 4. So I need to multiply this by 4 over 4. And when I do that, I will end up having this. That's going to be pi over 4 added to 8 pi over 4. So that will be 9 pi over 4. So that would be an angle that is coterminal to pi over 4 that's positive. Now if you want to do a negative one, you do the same thing, except this time you subtract 2 pi. And by subtracting 2 pi, you're going to get a negative number just because 2 pi is bigger than pi over 4. So get a common denominator. You want to go ahead and change that over like that. And then what we'll end up with is pi over 4 minus 8 pi over 4, like that. So that will give an answer of negative 7 pi over 4. So you don't need to convert these to degrees or anything. You just add 2 pi, subtract 2 pi when you're dealing with radian measure. Okay? All right. Next problem says, for the given angle, name the quadrant in which the terminal side lies in. Well, one thing that you get into on this is you can subtract 360. You can just keep subtracting 360 until you figure out where you are. This is one approach, and we're doing this calculator free now. Okay, so I'm going to just regroup, and I'm going to make that a 6. Got to regroup and make that a 12, so that's 961 degrees now. Okay, now we can take that down by 360 again. So now we get 106. So now we're at 601 degrees. And then we could do 601 degrees minus 360. Okay, so that's 1. Got to regroup like that. So that would end up being, when you do that, that would end up being, keep that as a 10. I'm sorry, you got to go like that. And then 10 minus 6 is 4, then 5 minus 3 is going to be 2, like that. So what's happened on this is we've got down to a point that we're now between 0 and 360. Okay, so that means that if you looked at this on a coordinate system, what this really means is we subtracted 360 3 times, so it would really mean that you're going counterclockwise once, twice, 3 times, like that. That's the rotations that you're going to go through. Now what's going to happen is we're going to go another 241. So if you count it out, now you got 90, 180, 270, just a little less than 270. So that's going to put you in quadrant 3. So that would be the answer to the problem, quadrant 3. And then one other thing I wanted to show you, there is an alternative approach to this problem if you want to do it this way, is you can do it like this. Is the way I do this, is I just divide by 360, okay? And, you know, division sometimes a little harder to do, but if you divided it in 3 times, you'd have 3 times 0 is 0, 3 times 6 is 18, 3 times 3 is 9, then you got the 10 like that. Now I'm doing a bad job of kind of writing these things. Let me erase that and write that a little better. Okay, so what I'm going to do with this again, when I'm doing the division, is 3 times 0 is 0, that goes there. 3 times 6 is 18, that goes there, carry the 1. 3 times 3 is 9, plus 1 is 10. Now if you do the subtraction, you got 1, you have to regroup, making that a 12 and that a 2. So that's going to be 4, and then that will end up being 241. So either way you look at it, you're going to get 241 degrees. Okay, like that. So that puts you in quadrant 3. Okay, next problem we could do kind of the same thing, is you could just start by adding 360 to it, if you want to. And you know, we get so reliant on calculators, what you're doing, this is a negative answer because 684 has a bigger absolute value than 360. So we need to really just subtract the 2. And that'll give 4 there, 2, and 324. So right now we're at negative 324. Now see, since that is less than 360 in the negative direction like that, well, then what you can do is you can just kind of plot out this angle, and this angle would basically go like this since it's negative. So really what we just found is we're really going 1 lap around the circle, but then we're doing 324 more. So if you count it out, that's negative 90, negative 180, negative 270. 324 puts you up in there. So the answer to that problem is B, you're in quadrant 1. Okay? So basically, if you try to get the angle between 0 and 360, then it's easy to tell what quadrant it's in. Okay, the next problem says find the measure of the smallest coterminal angle. So what we do on this is we got to add 360 on this. And again, we're looking for a possible positive measure. So we need to take 351 and we need to add 360 to it. Okay, that one you might be able to do in your head. Okay, that's going to be 9 degrees. So adding 360 is what you get. Okay, the next one, what we're going to do, if we find a smaller positive coterminal angle, I want to subtract. So that's 0, that's 5, 10, that would be 4. So that would be 240 degrees like that. So again, what this is really saying, graphically speaking, is you're going 1 lap around the circle, then you're going 240 degrees more. Okay. Okay, I'll move to the next page now. And what we're going to look at on this is just a little bit of calculation. Make sure that we're on track with doing some calculations without the calculator again. Okay, so to begin with this one, we've got 180 degrees. And we're going to subtract from that 100. Whoops. Sometimes this thing is so hard to write on. I'm just not used to this yet. All right, so let me get this write this a little cleaner. Sorry, I'm being a perfectionist here. Okay, so let's write this out. So we have 180 degrees, and we're going to subtract 114 degrees, 47 minutes, 2 seconds. Now this is all about regrouping, so I'd expect you to be able to do this kind of thing without a calculator. So what you basically have to do is you got to regroup from the 180 to make that 179 degrees, and then that's 60 minutes. Okay, the idea is 179 degrees 60 minutes is the same as 179 degrees plus 1 degree. Okay, now you got to take away regroup, so borrow from that to make that 59, and then give 60 seconds back. So the idea with that is 60 seconds make up a minute. So when we have 59 minutes, 60 seconds, that's really the same thing as 60 minutes. So that's the idea. Now what you're ready to do is you're basically ready to go through and subtract everything. So 60 minus 2 is going to be 58 minutes. 59 minus 54 is going to give 12 minutes. And then 9 minus 4 is 5. 7 minus 1 is 6. So that should be the answer to your problem then. So it's all about regrouping. I like to assign that because, a lot of times students, when they were in elementary school, learned how to regroup, but they never understood it. And a lot of times in elementary school, students just don't quite have the sophistication to understand what regrouping really is. So this is a pretty good example to help you understand that. All right, the next one's pretty similar. We're going to start with 90 degrees, and we're going to subtract from that 37 degrees, 17 minutes, and 54 seconds. Okay, so we need to regroup. So the idea with regrouping would be basically the same on this. Okay, you want to do this? Come on, behave. There we go. Okay, we're going to take away from that to make that 89 degrees. And since we take away, if we borrow, we have to give back. I always say if you borrow, give back, because if you don't, you are stealing. So don't steal. So give this back. So that gives 60 minutes. Okay, now you've got to borrow from that to make that 59, and then give back so that you don't steal. So that's going to be 60 seconds like that. Okay. Now what you're ready to do is you're ready to subtract, and you'll have the final answer problem. So 60 minus 54 is going to be 6 seconds. 59 minus 51 is going to be 42 minutes. And then this will be 52 degrees like that. So that should be the solution to that problem then. Okay, so you want to be prepared to be able to do a little bit of regrouping like that without a calculator when angles are in degrees, minutes, and seconds. Okay. All right, moving down, the next problem is very similar. We're going to try to find the angular measure of this angle alpha. Okay, and the key thing on here is if you count this out, that's 90 degrees, that's 180 degrees, this is 270 degrees. So this thing is less than the 270. So what you'd have to do on this problem to calculate this is you'd have to take 270 degrees and subtract from that 210 degrees, 46 minutes, and 37 seconds. So that's the math that you have to do on that. Remember, we're looking at the angle between 210 and 270, so that's the reason why we have to subtract. So again, we're going to regroup. This time we're going to take away a degree to make that 269 degrees. Give back the 60 minutes. If you take away, you give back. Take away, give back. Okay, like that. Now you are ready to finish up the problem. Okay, so if we do this, you would do 10 minus 7 is 3. That would be 5 minus 3, so that would be 23 seconds. One thing I always tell students to do when you're doing stuff by hand, check. 7 plus 3 is 10. Carry the 1. 3 plus 2 is 5. Plus 1 is 6. So check, so that you don't make any mistakes. Now we're doing 59 minus 46. So that's 23 minutes. Okay, whoops, see? How did I catch my mistake? I checked it. 5 minus 4 is 1. And I always do that. I think it's like real important. If you subtract, if you can go through and check in your head, then by all means just check, and that's how you catch these little blunders that we all make. So that would be 13. And then we'd have 9 minus 0 is 9. 6 minus 1 is 5. So the answer to that problem would be that it is a 59 degrees, 13 minutes, 23 second angle then. So that one's all about the regrouping. All right. Moving on to the next thing, we're going to convert to radians. Another thing that's pretty standard that you want to be sure that you know how to do is how to convert a degree measure to radians. So the way we learned how to do that is you multiply by pi over 180. Okay, because one of the things that we learned is that basically pi radians is equal to 180 degrees, And what that means, if you ever forget this, you can kind of think of it this way. If you took this equation and divided it by 180 degrees, what you would get is you would get that every time you have 1 degree, it's the same as pi over 180 radians. So that's the reason why you do that. Okay, so it really just sort of becomes an exercise in reducing. So I'm going to put that over 1. If you want to multiply straight across, that's going to be negative 36 pi over 180. And then we just need to kind of consider how we would reduce that fraction. You can reduce the fraction in 1 step or 2 steps or whatever it takes. One thing that I see, you might not see this, but I think probably most people are going to see at least that it divides by 9. So if you want to do that, you can start the reducing of the fraction that way, and then just carry on from that point. So 36 divided by 9 is 4. 180 divided by 9 is going to be 20. Then you can reduce in one more step. You can divide by 4 and then close it off. Now, if you see how to reduce this in one step, then that certainly is okay. But a lot of times you don't see that real well. So the final answer to this is going to be negative pi over 5. Okay? And you can check your answer on this. It's actually very easy to check your answer. If you just did negative 180 divided by 5, that would take you back to negative 36. So you can certainly take the time to tell that you're right on these problems if you choose to. Okay, next problem, same way. We're going to just say that 270 degrees is the same thing in radians as 270 times pi over 180. Like that. So if you multiply straight across, putting that over 1 if you need to, 270 pi over 180, then it just becomes, again, an exercise in dividing, reducing the fraction. So basically, you can cross out zeros because technically the reason you can do that is you're dividing by 10. So then what that would end up giving you then is you would have 27 pi over 18. And then you can see that they both divide by 9. And again, you can do this in one step if you choose to. So I'm going to go ahead and finish this up. Then we'll have our answer. So 27 divided by 9 is 3. 18 divided by 9 is 2. So that is 3 pi over 2. Again, you could check by just doing 3 times 180 over 2. And notice on this 180 over 2 is 90. 3 times 90 is 270. So it's very easy to check and make sure that you have a correct answer on these problems. Okay, so one thing I wanted to mention on this, just a little arithmetic thing. If you have a fraction, and if you had something like this, okay, well, you can cross out sets of zeros if they're at the end, but you can't do this. Every now and then I'll see a student do this. I'll see them go like that. Don't do that. That's like way wrong, okay? So don't do that. They got to be at the end, okay? Be careful about stuff like that. Okay, let's see. This one, finding two measures, measure of two angles, one positive and one negative, that are coterminal. What we're doing in this section primarily is we know that since we're dealing with radian measure here, if we want to find a positive angle that's coterminal to it, we just need to add 360. I think we did a few problems like this a few minutes ago. But 2 pi radians is the same as 360 degrees. So what we do is we just add 2 pi to that and put that over 1. You get a common denominator. And when you do that, we're going to multiply that by 5 over 5. Then we'll work out the arithmetic. So that's going to give you 2 pi over 5 plus 10 pi over 5. So the answer would be 12 pi over 5. So that is an angle that is coterminal to that. That's positive. Okay, now if you want to find the negative angle that's coterminal to it, well, you just do this. You take the 2 pi over 5 and you subtract 2 pi. Okay, so that would be done exactly the same way, just some fraction arithmetic. You want to be sure that you get your common denominator. Okay, and when you do that, subtract it, and you'll have a negative angle on this. So that's going to be 2 pi over 5 minus 10 pi over 5. So the result of that should be negative 8 pi over 5, like that. Okay, add 2 pi, subtract 2 pi. Okay, this one will be done the same way. Okay, so 2 pi over 7, you're going to add 2 pi over 1 to it. I'm going to go ahead and just get a common denominator. So multiply that by 7 over 7. That will give me 2 pi over 7 plus 14 pi over 7. So that's equal to 16 pi over 7. So that would be the result of the problem then. Okay, like that. Okay, so going back to the negative one now, what we're going to do is this. We're going to do 2 pi over 7, and we're going to subtract 2 pi, okay, to make the negative one. Okay, and so what we'll have here is put that over 1, multiply by 7 over 7 to introduce your common denominator. So that's 2 pi over 7 minus 14 pi over 7. So that gives equal to negative 12 pi over 7 as your negative angle that's coterminal to it. Okay, so it's a very simple thing to do. A little fraction arithmetic is involved too. Okay, now we'll move on, let's see, to the next page on the handout. And we want to look at sketching some angles would be the next thing that we have looked at. So let's work on that a little bit. Okay, so we're going to draw these angles in standard position. One of the things that you might want to do on this is when you draw these in standard position, it might be helpful on these two problems that I'm getting ready to do to change these to radians. So we might look at the problem that way then as we go through this. So let's go ahead and do that. Let's just take 7. We know that pi is equal to 180 degrees. So we can do this. 180 divided by 4 is 45. The way that you can do that in your head, if you divide by 4, you just take half of something twice. So 180, take half of it, you get 90. Half of that's 45. That's how you divide a number by 4, is you do that if you don't know that. And then if you do 45 times 7, if you don't know that in your head, you can work it out the side. That will give, what, 315 degrees. So now we're going to sketch this out. Okay, so it's a positive angle. Positive angles are measured like that, counterclockwise. So if you count this out, this is 0, that's 90, that's 180. Here is 270, and if you make it around the circle in one lap, that's 360. So what you're going to do is just do this. You're going to end up kind of counting this out for 315. That's going to be 90, 180, 270. So it's going to be really about halfway in the middle of the quadrant like that. So that's how you're going to draw your angle. The other thing you want to do is if I'm drawing an angle in standard position, you're always looking at the positive x-axis. The positive x-axis is the initial side of the angle, and then you have the radius would be the terminating side like that. So that's how you would basically draw that angle then. Okay, and we'll do the next one the same way, except this is a negative angle. So what we want to do on this is let's go ahead and get a coordinate system put together here, and then we'll get this put together. Okay, so same approach. Let's go ahead and take the pi and replace the pi with 180. Okay, reduce the fraction if you can. That's 45 again. And now if you take negative 3 times 45, you're going to get negative 135 degrees. Okay, now if you have a negative angle, remember you are going clockwise. Again, you need to start at the positive x-axis. That needs to be shaded in. And then just count it out. So if you go this way, that's negative 90. This is negative 180. So if you're going clockwise, you would end up being about halfway, exactly halfway in the middle like that. So that would be a good sketch of that angle. So one thing that you always want to do that's important, a lot of times I see students don't do this. They think it's unnecessary. It's actually very necessary to put that direction on there so that I can see that you're going clockwise or counterclockwise and that you're going around the correct number of rotations. Okay, so be cautious about doing that. Okay, let's see. Next problem, find the measure of the smallest positive coterminal angle. And we're going to leave the pi in the answer like this. So basically this is in radians, so we've done a lot of stuff on here in this problem. Well, okay, if you want it to go down by 360 degrees, well, you're really making it go down by 2 pi. So what you need to do is just take this and subtract 2 pi from it, and get a common denominator, of course, which would be 3. So I'm going to multiply the top and bottom by 3 over 3. And when I do that, then I'm ready to get the answer. So it's pretty simple arithmetic. You'd have 10 pi over 3 minus 6 pi over 3. So the solution of that problem would then be 4 pi over 3. Okay, and that's as small as you can get. If you subtracted 4 pi over 3 from that again, let me show you what happens if you subtracted 2 pi over 1 again. That would really be 4 pi over 3 minus 6 pi over 3. So notice you would get a negative answer. So that's the reason why you don't need to subtract 2 pi again. That would guarantee that it's the smallest positive coterminal angle then. Okay, and then the next problem, since it starts negative, we want to make that a positive coterminal. We add 360, but since we're dealing with radians, we want to add 2 pi to it like that. So when we do that, again, it's just common denominator time. So we're going to multiply that by 10 over 10. And then when we do that, we'll have negative 3 pi over 10 plus 20 pi over 10. Should give you a positive answer. So that would give you positive 17 pi over 10. And that would end up being the smallest. Why did I put a 180 there? Sometimes I can't talk and type at the same time. Okay. All right, so we get that erased, and then we'll put the correct answer with a 10 in there like that, okay? All right, so that's how that goes. That would be your solution to that problem, okay? Okay, moving to the next thing here. Number 18, given that angle theta is in alpha is in standard position, find the trig function on this, okay? All right, so what this is really saying on this is this. You don't really have to do a graph on this, but I just want to remind you of what is really going on this problem. This is really nothing more than looking at the definition of the sign. So if you went over, let's say that's negative 5, and let's say that's negative 10, and you're up 5 like this, so you're looking at a point that's to the left 9 and up 5 like this. So technically what you're looking at is you're looking at this ratio between y over r. The sine of alpha is equal to y over r. Okay, so you know in this problem that y is 5 and x is negative 9. So we know that 5 is a part of it. We just need to find what that radius r is. So we do that by the Pythagorean theorem. R squared equals x squared plus y squared. So we're going to have r squared equals negative 9 squared plus 5 squared. So that's going to give r squared equals 81 plus 25, which will give r squared equals 106. Then we can square root both sides, and we get r is equal to positive square root of 106. And remember, radius is always positive. So basically, there's your y value. We just crunched out your r value. So if we're finding the sine, it's the ratio of y over r, like that. And then what you want to go through and do, of course, you want to rationalize your denominator like we've been doing. That's just kind of a general rule of thumb, is we like these things to be in a rationalized form. So we multiply top and bottom by root 106. So the final answer to that problem is going to be 5 times the square root of 106 all over 106, like that. So it's just an exercise in knowing the definition of the sine and y over r. And you have to know the definitions that I'm giving to you. They're so fundamentally important to trig, you have to know them. Okay, the next problem we're going to do is looking at the tangent. Again, I'm not going to do a graph on this necessarily, because you don't necessarily have to do that. So basically, by definition, if you have a point, and that point's not on a unit circle, it's just on a circle, the tangent is y over x. So in this problem, well, there's y, there's x. I've given you that information. So that means the answer to the problem would be negative 9y over negative 8. And of course, you would reduce the negatives, so you would have the tangent of alpha is equal to 9/8 like that. Okay, next one is finding a cotangent. Okay, and again, we don't need to graph, it's just pull out the definition. The cotangent is x over y. So in this particular problem, x is 6, y is negative 7, so you would have 6 over negative 7. And we generally don't like to write a negative in the denominator, so the best ways to write the answer are either negative 6 over 7 or just put the negative directly in front of the fraction bar. Those are the two preferred ways that you write that. Most of the time you see it written with the negative in front of the fraction bar. All right, a few more of these, just kind of testing the definition. So we know that the secant of alpha by definition is r over x. Okay, I did give x. I did give y, but y is not necessary in this problem. I did not give r, so we have to find it. So we need to use the Pythagorean theorem. So we're going to do r squared equals x squared plus y squared. Okay, x is negative 3. Y is negative 2. So that will give r squared equals 9 plus 4. That's r squared equals 13. Square root both sides. R is equal to square root of 13. Okay, so when we get this put together then, we found r, got x. Okay, so the answer is r square root of 13 over x, negative 3. Again, learn to write the answer either this way, because you have a positive divided by a negative, or preferably even like that. Just understand that those are really two ways of writing the answer. It's not that this is wrong, it's just that it's not preferred. Okay? All right, let's move to page 4. And we look at page 4. We're going to do a couple more of those. I just want to do several of those because I'm really wanting to review all the different trig functions. So there's 6 trig functions, so you need to obviously know the definition of all those. Okay, so if we do the cosine, okay, the cosine by definition is x over r. So in this problem I gave x, and we need to find r. So we've got to use the Pythagorean theorem. R squared equals x squared plus y squared. So r squared is equal to 8 squared plus 5 squared. R squared then is 64 plus 25. So that would be r squared equals 89. Square root both sides. And remember, r is always positive. So now we're ready to get our ratio. So the ratio is x, which is 8, over r, which we just found. And then you can rationalize the denominator to get an answer to the problem. Okay, just always want denominators rationalized. That's pretty standard. Okay, do that, then we'll have an answer to the problem. And I don't mind if you rationalize denominators in your head. You're going to end up doing that so much it doesn't matter that you're going to kind of get that aspect down anyway. So you have 8 times the square root of 81 all over 81 as your final answer to that problem then. Okay, so just be sure that you get that in a rationalized form. Okay, next problem, we're doing a cosecant. So this will be the last of the trig functions. So the cosecant, by definition, is r over y. It's a reciprocal of the sine. So I did give the y value. So we got that, but we have to find r. Again, it's the same idea. Pythagorean theorem again. So it's r squared equals 18 squared. This is probably not a good problem to give a student on a non-calculator part of an exam. So I'm going to be a little lazy and get my calculator. Don't worry about that. I'm not going to give you gigantic numbers. The idea is there's a time for calculators and there's a time when you shouldn't have to reach for a calculator. And that's what we're trying to teach students. And calculators, sometimes if you always use them, you know, you lose a lot of your arithmetic skills. Now, trust me, I could do this problem without a calculator. I just don't want to, if that makes sense. So we got 324 plus 576, so that's 900. Yeah, it's just the numbers are too big. So we're going to end up having 900 there, square root both sides. And, you know, you don't really need a calculator to do this. It's just the square root of 9 is 3, but it would be 30. Because 30 times 30 is 900. Okay, so now when we go to getting our answer to our problem, the cosecant, I'll write that a little bit better. The cosecant is going to end up being r over x, or r over y. So we have cosecant of alpha is r over y. Well, r is 30. Y is 24. Then you can reduce that fraction. You can reduce that by a factor of 6 in your head. So 30 divided by 6 is 5. 24 divided by 6 is 4. So that means the solution to that problem is then going to be 5 fours. All right. Let's see, moving on to some other things on here. Let's take a look at finding the exact value without a calculator. Okay, this has to do with special triangles primarily. So what I would suggest you do on this is go ahead and convert this to degrees so we know where we are. So we're going to take 11 times 180 over 6. Again, you don't need a calculator for this because of the reducing. That's another reason why I want you to do things with and without a calculator. So that is going to be this. 180 over 6 is 30. And then we have 30 times 11 would be 330 degrees. You can work that out the side of your paper if you want to. All right, so let's take a look at basically then what's going on this problem. So if we were to go through and do a sketch of a 330 degree angle, let's go ahead and do that just on a coordinate system, make this look kind of cool. All right, so we're going clockwise. 330 is going to be a little less than all the way around a circle, so we're going to be looking at that. So what we're going to do is what we call a reference angle. So reference angles always go from the terminal point to the x-axis. They never go the y-axis. Okay, now we have to figure out this reference angle, which is right here. So 360 minus 330 is going to give you a leftover 30 degree reference angle. Okay, now we learned the triangle that goes like this. This is a 30-60 right triangle. So you have to know how the sides go on that. So that would be kind of one of the key things. So I always say that this is as easy as 1, 2 square root of 3. The 1 is the smallest. It goes opposite the smallest angle. 2 is the biggest number because square root of 3 is 1.7 approximately. So that's the hypotenuse. Then the square root of 3 would be that one like that. Okay, so when you do the sign is y over r. So if you look at this value, now this would be the y value, although y is -1 because of the quadrant we're in. Okay, so see what you basically have is you have the x value of square root of 3 and a y value of -1 when you have a radius of 2. So what you would have then is you would have this. Y would be -1. R would be 2, so that means the answer to sine of 11 pi over 6 is going to be -1/2. So you're reasoning that out with your knowledge of special triangles. So that's what we're going to be looking at here for a few minutes here. Okay, the next problem would be done with the same mindset. So the idea here would be, let's go ahead and just sketch out a graph on this and construct a 30 degree angle. Okay, so when we do this, of course, we're going to be in quadrant 1, so we're going to be going, of course, counterclockwise. So you can draw out this, and then draw your reference angle. So notice I'm going down to the x-axis. You don't go this way. Don't go towards y, go towards x. So that's a 30 degree angle. That means this is a 30-60 right triangle. So the sides are as easy as 1, 2, square root of 3. 1 goes there, 2 goes there, square root of 3 goes there. So technically you have a point. This is the x value. This is the y value. So you have that point. So now you've got everything that you need to know to figure out the problem. So the cosecant of 30, by definition, the cosecant's r over y. So r is going to be 2. Y is going to be 1. So that's 2 over 1. So that means the answer to that problem is 2, like that. Okay, so it's all about knowing your triangles, knowing your reference angles, and knowing your definitions. If you know those things, you'll succeed. If you don't, you probably die. Well, not literally. That's a bad thing to say. All right, let's see. Moving on, we're going to do one more like this. This is secant of pi over 4. Okay, so pi over 4 is really 180 over 4, which is 45 degrees. So again, what we're going to do is draw a diagram on that, which will correspond to a 45-45 right triangle. All right, so let's just sketch out a 45-degree angle. So it's clockwise, so we're going to be right halfway in the middle, like that. That's going to be your 45-degree angle. Again, your reference triangle, you draw down to the x-axis at a right angle. So you have a 45-45 right triangle. The sides on that go 1, 1, radical 2. Radical 2 is actually about 1.4. So the only thing that would make any sense on this is for the sides to basically go like this. Okay, the sides are going to go 1, 1, square root of 2. The 1s both go opposite the 45s. Okay, now when you get the answer to the problem, the secant by definition is r over x. So in this diagram, this is x. X is how far over you are. Y is how far up you are, so you have a point 1, 1. Okay, so when we do that then, we would end up having r is square root of 2. So that's your r value. X is that value. So square root of 2 over 1 is going to give you an answer of square root of 2. Problem done. Okay. All right, so that's what you need to be doing for your special triangles. You need to be sure that you know those and are able to work with your special triangles and your definitions of the trig functions. Okay. All right, next thing is we'll kind of look at our quadrantal angles. And we're going to take a look kind of at how these next three problems go. They're all pretty similar in one regard at least. So to begin with, let's draw a picture of a coordinate system on this one. And I'll go ahead and get a coordinate system developed for the second one. We'll do those kind of at the same time. And these things are what we call quadrantal angles, meaning that they show up on quadrants. Okay, so pi is 180 degrees. That's a positive number, so we're going clockwise. So what this means is you're going like that. And if you got a quadrantal angle, what you do is you just assume, you can, do it like this. You just pick r to be 1 for simplicity. So if you're going this way, that would be the value of r. And keep in mind that r is always a positive number. So when you do that, you would have this. X would be how far over you are. So you're to the left, so that's -1. Y would be how far up you are. So you're looking at that point, -1, 0. That means x is -1, y is 0. Just let r be 1. Technically, you could let r be anything you wanted to except 0, and the ratio would work out the same. But hey, keep it simple. Okay, so the secant, by definition, is going to be r over x. So we have r is 1 because we chose it to be 1. We have x is -1, just the way the logic worked out. So that means the answer to that is the secant of pi is -1. All right, so that's how that works out. Okay, next one, we got pi over 2. What in the world did I just do? Pi over 2, I'm going to go ahead and work that out. Now, pi over 2 is 90 degrees. So that's going to be clockwise, so we're going to be going counterclockwise to this point right here. The whole key is we got to consider what that point is. So again, the idea is the radius you really just can choose on a quadrantal. So for simplicity, just choose r to be 1. So we just need to figure out what x, y, and r are. R is 1 because we chose it. Now that would mean the x value is 0 and the y value is 1 because we're going up 1. Okay, the tangent's definition is y over x. So if you look at your diagram, y is 1, x is 0, so you have 1 over 0. So what's the deal with 1 over 0? You can't divide by 0. So that means that this trig function is undefined at this point. So you can't divide by 0. And a lot of times students forget that. They get on a test or something and they say, oh, I can't remember if dividing by 0 is undefined or 0 divided by is undefined. There's several ways to look at this. Oftentimes I tell students this: if you have a number n over 0, no, don't divide. That's one simple thing that'll usually kind of stick in students' heads. Division by 0 makes no sense. I mean, if you showed up to a meeting and you had, say, hey guys, I'm going to give everybody a cookie, and you had 0 cookies, well, you couldn't do that division. You can't divide by 0. It doesn't make any sense. Okay? All right. So let's move on. Pushing on, we got, I think now just want to kind of look at some calculations, a little bit more with a few things to get us straightened out here. So let's see. Let me zoom on this just a tad bit here so I can see. So let's see. Stuff from 1.4. This really, you're going to, at first glance, students will say, oh my God, I don't have a calculator, I can't do it. Yeah, you can. You can work this out without a calculator because the problem's designed so it's calculator. So what I'm checking you on this is the idea of a cofunction. Okay, so the idea is the sine and the cosine are what we call cofunctions. That's why we name it co, like that. And what we learned on this basically is that the angles are supplementary. So what we find is that if you have the sine of x degrees, then that's the same as the cosine of 90 minus x degrees. That's an identity we learned. They're the same. They will always give you the same value. One illustration of that I could show you that's kind of a slick thing to show students to help you understand this. It's like if you go back to that 30-60 right triangle where the sides go like this, I want you to notice that on this, the sine of 30 is equal to opposite over hypotenuse. Okay, like that. Now I got that totally. What in the world did I just do? That's a 2. Okay, gosh, come on. Careful, Brad. Okay, so that would be opposite over hypotenuse, so it's 1/2. Now, if we do the cosine of 60, which is a supplementary angle, what we get is adjacent over hypotenuse. It's the same thing. So that's what we mean by cofunctions then. So it turns out that these two things are the same. So what I'm going to do on this is I'm just going to change the cosine to a sine. It doesn't matter which one you change. So this thing right here is really the same as the sine of 5 degrees. So you can replace that with sine of 5 degrees, leaving that sine the way it is. Don't change it. And then same thing here, but what I'm going to do on this is so that I have 5 degrees, I'm going to change this sine to the cosine of 5 degrees by the same logic. So I'll have cosine of 5 degrees here times cosine of 5 degrees here. So what I have now is sine squared of 5 degrees plus cosine squared of 5 degrees. And we learned the identity that the sine squared of an angle plus cosine squared of the same angle is equal to 1. So that comes from the identity that we basically learned then. All right, so that is the idea with that one. That one's looking at cofunctions primarily as the idea. Okay, well, the next one, let's see. This one you'd really just gonna want to work out, kind of look at, these are quadrantal angles, so you want to just consider where these things are on a basic circle here. So to begin with, let's look at cosine of 360. Well, if we go around one lap around the circle, 360, we're going to be at a point that's quadrantal. So if you just consider r to be 1, then this x value is 1 and the y value is 0. So that would mean if you do the cosine of 360, the cosine's x over r. So x would be 1, r would be 1, so that's 1 over 1. Then when we go to the next thing, we're looking at 90 degrees. Okay, so on that, on a unit circle, that would be the point 0, 1. Okay, so the sine is y over r. So if we're looking at 90 degrees, y is 1, r is 1. So we'd have 1 over 1 like that. Now to work out the math on this, it looks like you'd have 1 minus 8. So you'd have a final answer of -7. So that would be the logic you go through on that. It's just an exercise in arithmetic and being able to figure out trig functions of special angles. That's the idea. Okay, next two problems, or three problems. I'm going to kind of go through this a little bit with you. And these are all about a coordinate system. Usually, hey, that's kind of cool with, that's not what I intended to do there, certainly. The idea with that is just make a chart up. And when you make this chart up, you should be able to find the place where the two conditions basically overlap. So let me draw a little coordinate system out on this. Okay, I'm trying to be all neat and everything. So the idea with this would be, if we did this, sometimes this mouse is so fuzzy. Okay, let's do this. All right, so the cosecant is positive. Now remember, the cosecant's definition is r over y. R is always positive, so the question becomes, where's y positive? Y is positive there, and it's positive there. That's where the cosecant's positive. That's where the sine is positive as well. Now the cotangent, if we were to look at the cotangent and trying to make the determination of where that's positive, well, that goes like this. The cotangent is x over y. So one thing is everything's positive there, but we also learned that the cotangent is positive in quadrant 3. And the reason is because if you're in quadrant 3, x is negative, not negative 1, but just some negative number. Y is some negative number. So a negative over a negative is a positive. So the question is, where do these overlap? They overlap there, so that means the answer to that problem is quadrant 1. So what you're doing is analysis of signs. That's how you can figure out these values. Okay, that's, to me, this is the easiest way to get students to do this correctly, is just make a little chart out kind of like this then. Okay, let's do the next one in a similar way. So I've given you two conditions. I've given you secant is positive. Now the secant is r over x. So it happens where x is positive. X is positive to the right of the y-axis. So our answer is now narrowed down to 1 or 4. When we look at the next condition, we're looking at where the cosecant is negative. The cosecant is r over y. So the question is, where is y negative? Y is negative downstairs, like that. Where did the two checks overlap? They overlapped there. So that means the answer to this problem must be quadrant 4. That's where those two conditions basically overlap one another. Okay, so that'll give the answer to that problem. Okay, and let's see, one more. To kind of close this idea off, I want to make sure you guys can do this okay. And this is a fundamentally important thing that we do in trigonometry all the time. Okay, so let's go ahead and get this worked out then. So let's get our conditions satisfied here. So the secant is negative. The secant, again, is r over x. Where is x negative? It's negative where x is negative. Okay, then we're going to look at the cotangent being negative. So the question becomes, where is the cotangent negative? Cotangent's x over y. So it turns out that would be where you have opposite signs. That's going to be negative in 4 and in 2. So those two conditions come together in quadrant 2. Okay, and I'll kind of review with you guys one thing on this too, that you can remember if you want to. Basically, all trig functions are positive in quadrant 1. Then we learned, I think, students, there's a little saying you can learn, all students take calculus. There's several of these. There's all science teachers crazy. And, hey, we're all adults. There's also all strippers take cash. I've heard that one before. So, all students take cash. Now I'm all messed up. All students take calculus. Okay, that's the politically correct one, even though it's not true. All right, so the idea is everything, like if you have the sine, cosine, and tangent, everything's positive in that quadrant. In quadrant 2, the sine's positive, but the other two are negative. And in this quadrant, quadrant 3, it goes like this. The tangent's positive, the other two are negative. And in this quadrant, the cosine is positive, the other two are negative. So it's just the sine being positive there because of the students, the tangent being positive there because of the take, and the cosine being positive there because of calculus. Okay? But that, all science teachers crazy, all strippers take cash, take your pick. Or invent your own one if you want to. Okay, let's see. Find the number 36. Find the acute angle that satisfies this equation. Now, what's going on this is if you're doing finding an angle, what you're really doing is you're really doing the inverse sine of square root of 2 over 2. So what we end up having on this basically is this situation. When we look at this, we need to probably just look at a little diagram on this. There's a couple of key things on this, and this really has something to do with a triangle. So the first thing that you absolutely have to pay attention to this is an inverse sine has a certain range to it. That range is between negative 90 degrees and 90 degrees. So that means that when you give me an answer to an inverse sine, your answer has to be this way, 90 degrees, or it has to be this way between 0 and negative 90 degrees. Those are your two choices. Well, since I gave you a positive value, a positive ratio for that sine, that means that you can't be here because the sine takes on a negative value in that quadrant. You have to be in quadrant 1. So what would happen on this problem then is you could draw a reference triangle, and then the sine is y over r. You could also think of it as, if you want to, as opposite over hypotenuse. Okay, but this one probably needs to be in a rationalized form to help you figure this out. So we're not used to having a square root of 2 in a rationalized form. So what I'm going to do with this one is I'm going to rationalize the numerator like this. So that's going to be 2 over 2 root 2. So that's going to be 1 over root 2. So the sine by definition is y over r. So that would mean r is square root of 2, y is 1, and then that would force x to be 1. So it would be the 45, 45 right triangle. So your job is to tell me the angle that has that sine. Well, 45 degrees is y over r. So that means the answer to this problem must be 45 degrees. A lot going on that problem to think about. Not complicated, but lots of picky details. You got to know that your answer has to be there. So typically, you're going to be working in quadrant 1 or quadrant 4 on an inverse sine. But if you're in quadrant 4, you have to make sure you give me the answer between 0 and negative 90. That's incredibly important on that. Okay, so the next problem will illustrate that a little bit more. So let's move on and look at the next one. So the idea with this one is if we, again, did a coordinate system and considered the things we need to consider on this, first of all, the answer to an inverse sine must always be in this interval. Okay, so you're either there or you're either there. Now, notice what I did on this problem, though, is I gave you that the sine of alpha is equal to negative 0.5. So that really means the sine of alpha is negative 1/2. The sine, by definition, is y over r. So we need to kind of work backwards with our special triangles to reason that out then. Okay, so where are we? Okay, well, the sine is positive here. So if you take the sine of a quadrant 1 angle, you're going to get a positive answer. If you take the sine of a quadrant 4 angle, you're going to get a negative. So we have to be there, see. So we're in this quadrant. So if we go through and draw ourselves a reference triangle, we're going to draw, again, up to the x-axis. And the sine is, this is y is negative 1. So that would be, the y value would be negative 1. R is 2. So it would be that. So this is the 1 square root of 3, 2 triangle, which goes like this. This would be 30, 60, 90, like that. So since the sine of 30 is y over r, then our answer is not 30 degrees. It is negative 30 degrees, okay? Because your answer has to be in that quadrant like that. So the sine, the inverse sine, if it's given as this, then theta, or alpha, must be negative 30 degrees. There is no other answer to that problem. Students a lot of times say, well, why can't I give 330 degrees? You can't because it's out of that range, see. So if you're doing an inverse sine of a negative number, the answer is going to be a negative angle that's in quadrant 4. Okay, it has to be between 0 and negative 90 if you're in quadrant 4. Okay, moving to the next one. What I want to look at here is, again, let's just do a diagram on this. So when I move to the next one, we're now looking at an inverse tangent. So we have the inverse tangent of 1. Our job is to find what that angle alpha is. Okay, well, the same thing happens on an inverse tangent. The range of answers on an inverse tangent are negative pi over 2 to pi over 2. So you can only give me an answer in radians that's between negative pi over 2 and pi over 2. It's the same as the sine, except there's parentheses because the tangent, you got to remember that the tangent of pi over 2 is undefined. So that's why we have those two parentheses like that. Okay, well, what we really are dealing with is when you look at 1, this problem is really saying tangent of theta equals 1. If you put that over 1, see, the definition of the tangent is y over x. And again, you're either, since you have this range of answers, then you're either there or you're there. This is a positive 1, so it means you're here. Okay? So if you went through and did this and just kind of made you a reference triangle, and if you went straight down the x-axis, okay, you could think of this being your angle alpha. Y would be 1, because it's given. X would be 1, because it's given. Well, that's the triangle that goes 45, 45, where the radius is square root of 2. So that means the answer to the angle would be 45 degrees. Okay, and it says find the answer in degrees. So that would be 45 degrees, like that. That's your answer. Okay. Those problems right there tend to challenge students a little bit. There's a lot of thinking that goes involved in that. But man, you got to pay attention to the area where your answers range from, and that's really important. Okay, moving on to a few other problems of this sort to get us finished up here. Okay, as we go through the next page, I want to do a little bit more repetition on that idea that I was just going through, because it is kind of challenging for students. So if we were to go through and do this same kind of diagram on this problem, this is basically what you would end up coming up with. Again, you're looking for an angle. Just because if I'm asking for an inverse trig function, I'm really asking this question. I'm asking the cosecant of alpha equals negative 2. I'm really asking you to find alpha. So you're finding an angle. All right, so what you'd have to realize on this one is the inverse cosine. The way inverse cosecant works is you end up being kind of basically like this. Of course, if you can be from 0 to 90 degrees. I do want the answer in this degrees. Or you could be down in this area right here. Okay, so the idea with this is the range of answers on this kind of turns out like this. One thing about if you're at this point right here, you're at the point 1, 0 there. Since the cosecant is r over y, the cosecant is undefined at 0. So you're undefined at 0 degrees. Okay, you would also find, since this point is 0, 1, well, if you did r over y there, you're okay. And if you go here, 0 to negative 1, r over y is also okay there, as you just have negative 1. So it turns out that the range of answers on this, your answers have to fall between 0 and 90 degrees including, and then they have to fall between negative 90 degrees to 0 but excluding 0. Okay, so your answers can only fall within there on an inverse cosecant. So it's kind of like the sine. If you had a cosecant of a quadrant 1 angle, you're going to get a positive answer. If you have a cosecant of a quadrant 4 angle, you're going to have a negative answer. So see, this basically puts us down in quadrant 4. So all we're going to do is we're going to draw a reference angle on this and just see if we can reason this out then. So what we would have then if we draw a reference triangle is we'd have this. Okay, so basically, if you look at this statement right here, look at the negative 2 over 1. Okay, the definition of the inverse cosecant is r over y. So that means the r value has to be 2. Now, r can't be negative 2 because r is always positive. It's y that's negative 1. Okay, and then that's going to force you to have these ratios of sides like we've learned here. So that is going to be a 30-degree angle. So the final answer of this problem is not 30. The final answer is alpha equals negative 30 degrees because of this. An inverse cosecant is defined on that interval. A lot of picky details on these problems. You got to be really, really careful when you do these problems about that. But they basically are an analysis of figuring out the quadrant you're in and whatever that reference angle ends up being. That's the basic idea. You got to study that. Okay, let's see. Next one, again, let's do a diagram on this one. That's always a good way to start off the problems, is by a diagram. And then let's kind of consider what's going on the problem. So this problem, what it's really saying is the sine of alpha is equal to negative 1. Trying to find an angle that has a sine that's negative 1. Well, you can put that over 1, and then by definition, see, the sine is y over r. So you want to kind of reason out on a unit circle where such a thing would exist. So you got to think about that a little bit, okay? So the only place on a unit circle where y becomes negative 1 is down at this point right here. Okay, that's the only place that's the only possible place where this could happen, because you have a radius that's going to be equal to 1. If that's the case, then the y value has to be the same. So that's what you're looking at, is this. Now remember the range of answers. You're only allowed to give me answers from negative 90 to 90 on an inverse sine. So anything that's outside of that range is unacceptable. So you could not say 270 degrees. You have to say alpha equals negative 90 degrees to be within that range. Okay, like that. So that answer to that problem is negative 90 degrees. Study this, practice them. This is always a problem area for students. There's a lot going on to think about. Okay, move down to this one and do one last problem like this. So if we move to the next idea, actually I'm going to do two problems like this. A lot of repetitions usually needed on this. So let's take a look at what's going on in this problem. Okay, so this problem really means the sine of alpha is equal to 1/2. Your job is to find alpha. Okay, these are the things you consider. The sine by definition is y over r. So you got to figure out what triangle or what point would represent that. The other thing to consider is the range of answers on an inverse sine is negative 90 to 90. So you're either there or you're there. And the idea is the sine of a quadrant 1 angle is going to give you a positive answer. The sine of a quadrant 4 angle is going to give you a negative answer. So you cannot be there because I gave you a positive 1/2, say. So that means that where you are in this is you're in quadrant 1. So we're going to draw a quadrant 1 reference triangle and try to figure out what's going on. Okay, so I'm going to go straight down to the x-axis. Okay, r is 2. Remember, that's what I gave you. Y is 1. So I gave you that. That means x is square root of 3. So you have the triangle that goes 30, 60. So that means the answer to this problem is 30 degrees. Okay, so that is how the reasoning of that goes, is look at the triangle or look at the quadrantal angle that will give that value. All right, one last one here. And whenever you see a sine or a cosine of 1, you have to start thinking about more of the quadrantal situation here. So let's see what we got going on here. All right, so what this problem again really means is this. Okay, it means the cosine of alpha is equal to 1. Your job is to find alpha. Now, if you put that over 1, the definition of the cosine is x over r. So the thing about an inverse cosine, now this is different on an inverse cosine. The range of your answers, they must fall between 0 and 180 degrees. That's the definition. So you have to be in either quadrant 1 or quadrant 2, and your answer has to be a positive angle between 0 and 180. So if you reason this out a little bit, and if you just look at a couple of points on a circle, like if you looked at this point right here, r is 1 because of what I gave you. So if r is 1, and you have a circle going around that point right there, the only thing that would make any sense would be for this point to be 1, 0. Okay, so x is 1, y is 0. So that means in this particular problem is, well, what's that angle? Okay, that angle has to fall there, so you couldn't say 360 because 360 is out of range. You couldn't say negative 360. That's out of range, but hey, 0 is in range. 0 is cool. So the answer to that problem is 0. Cosine of 0 is equal to 1. Okay, all right. Now let's see a few other things. Let's see, I'm going to move over here, and then we'll begin to look at, review some basic triangles here. Okay, so you can kind of look at this like this. One of the things we learned on this is, I taught you this. There's several ways you can do this. One thing I said, okay, you got sine, you got cosine, you got tangent. Okay, if you think about those, sometimes people like to use SOHCAHTOA. I don't like SOHCAHTOA because I never can remember how to spell it. SOHCAHTOA. So my preference is Oscar has, he has a pet donkey. He has a, why did I put a T there? What in the world's wrong with me? H. Oscar has a hairy old donkey, but we prefer to call his donkey his ass. Okay, so Oscar has a hairy old ass. So here's what we have on this. We're looking at alpha. So the side opposite is this. The hypotenuse is this. So that means the answer is 28 over 35. And then you could reduce that fraction by a factor of 7 to get a reduced answer to that problem then. Okay, so divide by 7, and then we'll have what that ratio is. So the solution should be 4/5. Oscar has a hairy old donkey. Just remember that and everything will go well. All right. So the next one, we're going to look at a tangent. Okay, now the tangent's definition goes like this. The tangent's definition, in terms of a triangle, is the side opposite over the side adjacent. So what we need to do on this is look at our alpha. Opposite is this. Adjacent is this. The hypotenuse is 52. So the opposite is on the other side of the triangle. Adjacent is the side of the triangle that's next to the angle that's not the hypotenuse. So what we would have on this is opposite over adjacent. So that is going to be 20 over 48. Again, you can reduce that fraction, it looks like, by 4. So if you divide by 4, then you'll have the final answer to the problem on that. And then we got a good answer to the problem. Okay, so that is going to be 5 over 12. All right, so in this problem, the tangent of alpha is equal to 5 over 12. So it's basically just applying definitions that you have to know for a right triangle. All right. Okay, next one. Let's take a look at this one. So the cosine of beta, by definition, is adjacent over hypotenuse. Okay, is the definition. So if you look at beta, adjacent is 40. Hypotenuse is the longest side, so that's 41. So we would say the cosine of beta equals adjacent, which is 40 over 41. Now that's already reduced, so that would be the answer to the problem. That one's pretty straightforward. No reducing of arithmetic required. So you've got the ratio written out. Ooh, a pretty purple highlighter. How cool is that? All right. Well, let's see. A couple other, I guess, ideas from 1.6 that I want to kind of finish up here then. This particular problem gives, our job is ultimately to find the sine of alpha. So that's what we're going to do. So ultimately that means that we need to figure out what y over r is, because that's the definition. Now they gave you two clues. They gave you the cosine of alpha is 8/9. Well, the definition of the cosine is x over r, so that means you have been given that x is 8. You have been given that r is 9. Okay, but the other thing they do is they're going to give you a hint as to that'll kind of help you figure out what y is. And we'll get to that in a minute with quadrant 4. So we need to use the Pythagorean theorem. We know that r squared is equal to x squared plus y squared. So we have 9 squared equals 8 squared plus y squared. So that's going to be 81 equals 64 plus y squared. So 81 minus 64, we need to go ahead and subtract 64 from both sides. So let's see, that'll give 11 minus 4 is 7. That should give 17 is equal to y squared. Okay, we need to do the square root of both sides. Now remember, technically you have a plus or minus. So right now, y is equal to plus or minus square root of 17. But the quadrant 4 narrows this down. See, if you're in quadrant 4, y is negative. Okay, so you'd end up for y having negative square root of 17. All y values in quadrant 4 are negative. So now we're ready to get the answer to the problem. Okay, we have the y value is negative square root of 17. The r value is 9. There's your answer. Okay, so that one is basically analysis of the x, y, r definitions of the trig functions. And I've given you enough information to solve that without having to rely on a calculator. Okay, moving on to the next slide here. Okay, so let's see, 47, I think this is about the end of it, if I remember. Okay, hallelujah. Okay, so let's go through and reason out these two problems here, just kind of by the same analytical technique. Okay, our job is to find the cosine of alpha. So if I want you to find the cosine of alpha, immediately what should come to mind is my job is to find what x and r are. Well, let's see, I probably have given you enough clues. What do you bet? You're like a mathematical detective. You're being given clues, you're figuring out the crime. All right, so we got sine is y over r. So that means this, y is 5, r is 7. Okay, so we need to figure out what x is and figure out the sign of it and everything, whether it's positive or negative, by the clues of the problem. So y is 5, r is 7. We need to figure out by the Pythagorean theorem what x is. Okay, so we know that r squared equals x squared plus y squared. So we're going to have 7 to the second equals x to the second plus 5 to the second. So that's 49 equals x to the second plus 25. So I can subtract 25 from both sides. That's going to give x squared equals 9 minus 5 is 24. So we need to do the square root of both sides. So that's going to give x equals, and technically at this stage it's still plus minus square root of 24. Okay, now a problem like that you need to reduce too. So that is plus minus 4 radical 6. So that means x is plus or minus 2 radical 6, like that. Okay, now let's figure out what quadrant it is. But now see, they also tell us the cosine's negative. Okay, so that means if the cosine's negative, well then x has to be negative. It has to be. Okay, I mean, it can't be anything else because the cosine's x over r, so now you can go ahead and write the answer to the problem. So cosine alpha is x. Again, in this problem, x we figured out to be this over r. Okay, so now we are ready to write our answer to the problem. So x is negative 2 root 6 over 7. That would be the final solution to the problem. Okay, let's do some reference angles. Okay, so reference angles, basically what's going on a reference angle is you're looking for an angle that's an acute angle between 0 and 90 degrees. So let me set up a couple of coordinate systems here and get that kind of set up so I can give a pretty good illustration of how this goes, what's going on with this thing. Okay, so let me get that put together. All right, then we'll move down here and let's do one more because I want to give you a good picture of what's going on this, and I want this to look professional and tidy and everything. All right, so let's draw pictures here. Okay, so 52-degree angle is already in quadrant 1. It's already an acute angle. So that means the answer to this problem is 52 degrees. Okay, what a reference angle is it's always looking at the x-axis and the terminating point. And it's always a positive answer. So your answer must be positive, and it must be between 0 degrees and 90 degrees. It's an acute angle. So that's how reference angles always work. Okay, next one is bigger than 1 lap around the circle, so I'm going to do 426 minus 360. So that's 6. You've got to regroup. That is 66 degrees. So what this means is you're basically going 1 lap around the circle, then 66 more. So again, with this problem, you always draw from the tip of that radius, and then that reference angle 66 degrees. Okay, so that would be the answer of the problem. Your answer is an acute angle. Okay, next problem, 92 degrees. Okay, well, we know that from here to here is 90, so we just are a smidgen. A smidgen, by the way, is not a very precise mathematical term. So what we really have is 92 minus 90, but that is not what we're looking for in a reference angle at all. I see students do that all the time. Be careful about that. There's a tendency to think that. What you need to do is bring that down to the x-axis. Your job is to find this angle right there, not this angle. I see that all the time. That angle is between the x-axis and that radius. So actually what you have to do on this problem is you have to do 180 minus 92. If you work that out, that's 88 degrees. So the answer to this problem is that reference angle is 88 degrees. So if you're in quadrant 2, you do 180 minus the angle I give you in order to get that reference angle. Okay. Right, here's another one right here on number 51. So number 51 goes like this. I'll go ahead. What? Wow, 3-dimensional. How cool is that? How do I get rid of that? There we go. Okay. If you take Calculus 3, you'll learn about 3-dimensional points. Okay, so here's our coordinate system. And let's sketch this one out now. Now, this one is clockwise. So if you did 411 minus 360, now you're going to have a leftover negative on this. This would go like this. It's 51 degrees. So what's happening on this problem is it's going like this. It's going clockwise, which is negative 360, but then it's going an additional 51 to get to that point. So you basically are going to be terminating in quadrant 4. Okay, so we do that. So let's see. Again, draw that reference triangle up to the x-axis. Okay, that angle is 51 degrees. It's not negative 51, it's 51. Reference angles are always positive. Be sure that you pay very close attention to that when you're doing your exam. Okay, next problem. Reference angles are going to be used to find exact values of trig functions. Okay, so let's go ahead and take a look at a couple of these things to finish this up. And these things are going to have a lot to do at this stage with working out special triangles and stuff. That's mainly what you kind of get into in these problems then. Okay, so let's see what we got going on here. Okay, with this number 52. Now we're going to, probably the best thing to do on this problem at this stage is just go ahead and see what this is in terms of degrees. So you have 5 times 180 over 4. 180 over 4 is 45. And if you work out the math on that, you're going to get 225 degrees. So what you want to do is sketch an angle out that is 225 degrees. So count it out. 90, 180, 225 is between 180 and 270. Okay, so you're going to have a terminating ray in that position like that. So again, you draw to the x-axis. That's very critical as you draw the x-axis. Now we need to go through and figure out what all these angles are now. Okay, so this is your reference angle right here. So that reference angle is going to be 225 less the 180 is going to be a leftover 45 degree reference angle. Just think that 180 plus 45 gives you 225, see? So that gives you a 45-45 right triangle. So the sides go 1, 1, square root of 2. Okay? Now our job is to find the sine, so the sine's y over r. Okay? The y value would be this, but technically this point would be -1 for x, -1 for y, because you're going left and down. So that means the answer to this problem is going to be y is -1 over square root of 2. Then you would need to rationalize that denominator, so you would get negative square root of 2 over 2 like that as your final answer. Okay? That's how it goes. You've got to look at the reference triangle. That's the idea. Okay, next problem, let's do a similar thing. Convert it. 7 times 180 over 6. 180 over 6 is 30. 30 times 7 is 210 degrees. So draw your picture. 90, 180, and a little more. Okay, we are in quadrant 3 this time. And if we're in quadrant 3, the point has a negative x and it has a negative y. Okay, so we need to figure out what that reference angle is. So that reference angle is 210 less 180. So that is a 30 degree reference angle. So when we draw our reference triangle, we need to be looking at that reference angle. And 30 degrees is, of course, going with a 30-60 right triangle. So you'll have 30 degrees there, 60 there, 90 there, so the sides go 1, 2, square root of 3. Okay? So the tangent by definition is y over x. So in this problem, y is going to be this value, -1. X is going to be this value, negative square root of 3. So you'd have y, -1, over x, negative square root of 3. So you do that. It becomes a positive answer. The two negatives divide out. And then if you rationalize that, you get square root of 3 over 3. Okay, let's see what else got here. One last problem, the last problem. Hallelujah. So 7 times 180 over 4, that's 45. Okay, now if we take 45 times 7, let's see what we get here. 5 times 7 is 35. That's 28 plus 3 would be 315 degrees. So we're looking at a 315 degree angle. Count it out. 90, 180, 270. It's not quite all the way around a circle. So draw your picture. Reference angle always goes where? X-axis. Okay, like that. So now we got to figure out this reference angle right here. So that would be 360 all the way around the circle, less the 315 would be 45 degrees. Okay, so what you have in this problem then is you're dealing with a 45 degree angle, another 45 degree angle there. The sides go 1 there, square root of 2. Okay, so when we do the cosine now, it goes like this. The cosine of 315 degrees, by definition, is x over r. Okay, x is represented by this value, and x is positive, since you're in quadrant 4. R is represented by that number, so you have that. Rationalize the denominator by doing this, so you will get square root of 2 over 2 as your final answer to your problem. Okay. Okay, so that will be the end of this. A lot of problems, a lot of things to study. Boy, if you get this stuff down, though, you got the foundation for trig, because these are all the foundational things that we'll use the rest of the semester. All right, hope you enjoyed that. Hope that helped you learn some things well. Oh, shit. Brad, You idiot. You forgot to resume, you idiot. No, you didn't. Okay, just forget about Brad cussing and thinking he screwed up on this. I am okay.